students, today's video lecture is based on class 12 physics, that is the lecture number 9 of chapter number 1st. So today we will start with the topic electric dipole. Electric dipole. Actually, electric dipole is the system in which two opposite charges are present at some distance. Like suppose that there is a positive charge plus q and next is negative charge minus q. If these charges are present at a certain distance, so this type of system is known as electric dipole. In this case, there will be the midpoint of the charges and the distance from the charge to the midpoint, suppose that is L, and this will be also L. So we can write here the total length between these charges is 2L. So this is the electric dipole. Now in this case, the system in which two different charges is present at a distance of 2L, that is known as electric dipole. And this system is a system in which two different charges are present. That means if first is positive, then second will be negative. For example, HCl is a molecule. HCl, that is the molecule, and this molecule is formed by the combining of hydrogen and chlorine. And here is the hydrogen, that is the atom number first, and the second atom is chlorine. When these atoms are combined together, then they will form a molecule of HCl. So here is the hydrogen and next is chlorine. We know that at the hydrogen there will be plus, and here is the chlorine, that will be minus. So we can say here is the positive charge and next is negative charge, and these charges are present at a distance that is known as bond in chemistry. केमिस्ट्री में हम लोग किसी भी एटम के बीच की जो डिस्टेंस होती है जिससे मॉलिक्यूल बनता है, सो सपोज दैट यहाँ पर हाइड्रोजन और क्लोरीन के बीच की जो डिस्टेंस होती है उसको बॉन्ड लेंथ बोलते हैं. सो इसी डिस्टेंस को हम लोग अपनी फिजिक्स में डिनोट करेंगे 2L से. So here is the hydrogen that will be denoted as positive and chlorine will be denoted as negative. So if hydrogen and chlorine are combined together, then they will form hydrogen chloride, that is the molecule of HCl. So here is the midpoint of these charges, and from this point, this length is L, then also with this length will be equal to L. Now here is the positive charge, next is negative charge. So this system is a electric dipole. So HCl is the electric dipole. Clear that it is a system. Now we can calculate the dipole moment. What is the dipole moment? In this case, we can find it in the form of formula. So next topic is electric dipole moment. Electric dipole moment can be defined as defined as the product of one of these charge and the distance between these charges and the distance between these charges. Here is the one of these charges. किसी एक ही चार्ज को लेना है दोनों में से. Suppose that here is the dipole moment in the system of electric dipole. Here is the positive charge, that is plus q, and next is minus q. In this condition, the total length between these charges, that is 2l. So we will take just only one charge in this formula, and the total distance is 2l. So point number first is, in this case, electric dipole moment is denoted by P, and point number second is P equals to one of these charges. So take here Q, don't take minus or plus sign, only the magnitude of that charge. So write here Q into the distance between these charges, that is 2l. So the total distance between these charges is 2l. So write here 2l. So that is the formula for the electric dipole moment, and it is also can be written as P equals to 2ql. That is the another way. The formula is same, but the way to write this is different. So that's the formula for the electric dipole moment. And in the point number third, we can find the unit of P, that's equal to unit of Q, that is coulomb, and the unit of distance, that is meter. So the unit of P equals to coulomb into meter, that is C for coulomb and M for meter. So write here coulomb into meter, that is the unit of P. And in point number 4, we can find the dimension of P. So we can find here, there is the coulomb into meter, and the dimension of coulomb is AT. So write here AT, and for the meter, the dimension is L. So here is the LTA is the dimension of electric dipole moment. So here is the topic that's related to electric dipole moment. But in the next cases, by this electric dipole, how much electric field can be generated or created at any point? So there will be three conditions. That will be, first is axial position, and second will be equatorial position, and third will be at any point intensity of electric field due to electric dipole. So here is the point. According to this point, there will be three conditions. Actually, we know that if there is a system of positive and negative charge, that is the electric dipole, and the distance between these charges is 2l, and we can take any point on the axis of this dipole, that is the axial position. Suppose that there is a point P. So the first point is axial position. Axial position. Second is equatorial position. And third is at any point. At any point. What is equatorial position? If we are taking this point P on the axis of electric dipole, so that will be axial. But this point, if it is located vertically upward or downward to this system, that is known as equatorial position. In this case, and it is also known as broadside on. Broadside on position. Broadside on position. And this is end on position. End on position. Clear that? There are the two names. The main that's name which is in frame, that is the broadside on position. Broadside on position means this point will lie vertically upward or downward to this system. Then it will be broadside on position. Otherwise, if this point P is not lying on axis or broadside on, it will lie between this here and here and here and here. Then that's all point. That is the point number third. It is at any point. So we will first start axial position, that is end on position. Clear that? So first we will draw here, that is the charge plus Q, and next is charge minus Q. This is the electric dipole, and the distance between this point, the distance between these charges, that is 2L, and from the midpoint it will be L, and also be the distance is L for this charge. Suppose that on the axis of this system there is a point P where we have to find the intensity of electric field due to the electric dipole. Now in this case, let the distance from the point P to the midpoint of this system is R. We are supposing that. And if the distance between P and the midpoint of the system, that is O, is R, then the distance between minus Q charge and the point P will be, this distance is R, and if we will subtract the distance L, then it will be R minus L. Clear that? And the distance from the charge plus Q to the point P will be R plus L. So right here this distance is R plus L. Clear? Now we can go to solve this equation. Like we have to find the formula in the term of electric dipole moment. Now we can see here clearly, this is the electric dipole, and on the axial position there is the point P where we want to calculate the intensity of electric field. Then we can say here at the point P, due to minus Q charge, the intensity of electric field will be in this direction. Suppose that here is the point, that is charge 2, and this is the charge first. In this case, due to the charge minus q, suppose that there is the intensity of electric field is E2. But at the point P, due to the charge plus q, there will be electric field in this direction. Why we are taking here the direction opposite to each other? We know that in previous lectures we have discussed about the lines of forces, electric lines of forces. In that topic we discussed about that all the electric lines of force comes to the negative charge and goes from the positive charge. See here, for the positive charge, all the electric lines of force will go from the positive charge and goes to the negative charge. By this concept, the direction of electric field in this condition towards the negative charge. So I am taking here the direction towards the negative charge due to the charge minus q, and due to the charge plus q, there will be outward direction. See here, clear that? So here is the E1. Clear? So then what is the net intensity of electric field? Because this minus q is near to the point P. So the effect of intensity of electric field due to the negative charge minus q will be greater than the charge plus q. So the net electric field will be E2 minus E1. Clear that? Now here is the let intensity of electric field due to charge plus q, that is E1 equals to 1 upon 4 pi epsilon naught q upon r square. That is the formula which is described in previous class. That is E1. So take here equation number first. Next question is that there is the next topic, and we can say the next question: what is the intensity of electric field due to negative charge? So right here, let intensity of electric field due to charge minus q. So that is E2. In this condition, E2 equals to 1 upon 4 pi epsilon naught q by r square. That is the equation number second. Now we want to calculate the net इलेक्ट्रिक फील्ड। एक्चुअल में ये जो आर स्क्वायर है ये डिस्टेंस होता है उसके बीच का। इस आर के लिए here is the E1 stands for the charge plus q, so write for the plus q distance is r plus l, so write here E1 equals to 1 upon 4 pi epsilon naught q upon r plus l whole square, that is the equation number 1. And for this E2 equals to 1 upon 4 pi epsilon naught q by in place of this r square, this is the charge minus 2 is here, and distance, the effective distance is r minus l. So in place of this, we can write here r minus l. So write here r minus l whole square. That is the equation number 2. So net electric intensity of electric field, net intensity of electric field equals to E2 minus E1. Why we are taking here E2 minus E1? Because E2 is greater than E1, so the magnitude will be always positive. So we are writing here E2 minus E1 equals to, in place of E2, we can write this 1 upon 4 pi epsilon naught q upon r minus l whole square, and minus in place of E1, we can write this formula. And now 1 upon 4 pi epsilon naught q upon, here will be r plus l whole square for this. And we can see here 1 upon 4 pi epsilon naught is here, already this term is next. Q in the first term, also q is present in second term. So we can take common, that is q upon 4 pi epsilon naught in bracket 1 upon r minus l whole square minus 1 upon r plus l whole square. In the next term, we can solve it. Now if we are simplifying that term, then E equals to, we can cross multiply this. So q upon 4 pi epsilon naught into, in this bracket, if we are multiplying here and this will be here, so r plus l whole square minus r minus l whole square upon, by multiplying this, we can write here r square minus l square for whole square, because first bracket, in the first bracket r minus l, and in the second bracket r plus l. So this will be r square minus l square, and also take here square, so take square in this line, and E equals to q upon 4 pi epsilon naught this bracket, so it will be r square plus l square plus 2rl for this, and in next bracket there will be r square plus l square minus 2rl for this, and in denominator r square minus l square to the whole square. Now equals to q upon 4 pi epsilon naught in the bracket r square plus l square plus 2rl. If we are opening this bracket, then all the signs will be changed. Minus r square, and this will be minus l square, and minus into minus, that's equal to plus, that is 2rl. And in denominator r square minus l square to the power 2. And here is the r square and l square are positive, and here is the negative. So cancel these terms. 2rl plus 2rl equals to 4rl. So equals to q upon 4 pi epsilon naught 4rl, and divide by, here the r square minus l square to the power 2. So r square minus l square and take whole square. If the distance r square is greater than to the l square, if r is greater than l, so l square can be neglected. L square can be neglected. That means r के रेस्पेक्ट में अगर l बहुत ही स्मॉल है, सो उसकी वैल्यू एल स्क्वायर की और भी स्मॉल आएगी। सो ये बोल सकते हैं कि एल स्क्वायर को निगलेक्ट कर सकते हैं, दैट इज 0। सो E equals to Q upon 4 pi epsilon naught 4 RL upon, in place of this L square we can write 0. So here will be R square and also take square. So it will be R to the power 4 from this term. Now in place of this E equal to 2QL we are taking here, and also into 2 because here is the 4. So 2 into 2 equals to 4 and Q R L. So here Q into L and into R upon, here is the R to the power 4 into 1 upon 4 pi epsilon naught. Now E equals to, take this term first, 1 upon 4 pi epsilon naught, and here will be this term is equals to P. Clear that? And this will be cancelled by this. So here will be 2P upon RQ. But why? Because we know that P equals to 2QL, and there is the power 4, and in numerator there is also present R. So here is the only RQ, and in place of 2QL we can write P. And also here is the 2, so write 2. So the final answer for the axial position is E equals to 1 upon 4 pi epsilon naught 2p upon RQ. That is the formula for the axial position, and this is the intensity of electric field due to the electric dipole at any point, and that point is present in down position. Clear that? In the next video lecture we will start second topic, that is the broadside down position. Clear? So today we will stop here. So thank you.